Hello everyone. In this lesson, we will work with extreme values and we expand the idea of extreme values into electrical electronics applications. So how does extreme value relate to electrical electronics? So first of all, extreme values representing maximum or minimum points. So in electrical electronics, you've heard the terms that you may reach the maximum current or minimum current or maximum voltage or minimum voltage. Okay, so in working with the extreme value for electrical electronic applications, we are going to be more practical and we will take a look at the graph to see whether or not we have a maximum or minimum points. In some cases, we can use a derivative test to figure out if we have a maximum points or a minimum points. However, most of the concept is still the same as we have done in previous lesson. So maximum and minimum point occurs at the point where the slope of the line tangent to the curve at that given point is equal to 0. Okay, so we are talking about the tangent line which is horizontal and parallel to the x-axis. So, and the slope of that line has to be equal to 0. So the slope is defined as the derivative. So then you have to set the derivative equal to 0 in order for you to solve for x. And then you substitute that value for x into your original equation to find the coordinate. And then you use a second derivative test to figure out whether or not you have maximum or minimum. However, in a circuit, the instantaneous current, the charge, the power, and the voltage will reach their extreme values at certain point. Then the extreme values can be determined by the method similar to what I have discussed above for everyone. Okay, so I summarize the step into this chart, okay, into this box. Determine the extreme values in the circuit. You want to determine the equation if it's not given to you. Then you differentiate the equation, then set the resulting equation equal to 0. You solve for the unknown, and you substitute the solution into the original equation. And we are going to put that point on the graph to see whether or not we have the maximum or the minimum values. And sometimes because of it is electrical electronics related, you can see right away it's a practical value, it's a real values. So you probably know right away whether or not your values reaching a max or your values reaching a minimum. Okay, so let's get started with this example. I am asking everyone to find the maximum and minimum times in second and the corresponding maximum and minimum charge of this equation chart given in terms of time. Okay, so this is straightforward. So all I do is just I don't have to determine the equation because it's given to me already. I would differentiate the equation and I set the resulting equation equal to 0. Okay, so let's do that. So I am going to rewrite my Q. Q is given to me as 4t to the exponent 3 subtract 3 times t to the exponent 4. So I differentiate this in terms of time. I should have 12t squared subtract 12t to the exponent 3. Okay, so at this point, everyone knows how to differentiate because it's simple now. 3 times 4 is 12. Take 1 away from the exponent. 4 times 3 is 12. Take 1 away from the exponent, so it's become 3. And then according to the step that I should set the resulting equation equal to 0. So I'm going to set this equal to 0 now. Okay, then solve for t, right? The unknown in this case is the t. So as you see right here, you are having t to the exponent 3 and t to the exponent 2. So you may have more than one solution for t. However, in this case, we will find two solutions for t. Okay, so I am going to set this equal to 0. And at the same time, I will factor out what I can factor. So for this equation, I can factor out the 12t squared. And then what I have left inside the brackets is 1 minus t equal to 0. Then what I see here is I can have either 12t squared equal to 0. This will give me t equal to 0, obviously. Or I can have this one 1 minus t equal to 0. Then in this case, I will have minus t equal to minus 1. So t is equal to 1. So there are two solutions for t's. One is 0 and one is equal to 1. Okay, so if you end up with a negative value for t, then I think you may want to take a look at the graph to see if it's a real value or not. All right, okay. So then what I have to do next in the step is tell me to substitute the solution into the original equation. So I will have two values for q here, the corresponding value for q, because I have the two solution for time. So I will say I substitute t equal to 0 and t equal to 1 into q equal to 4t to the exponent 3 subtract 3 times t to the exponent 4. So then I will have q of 0 equal to 4 times 0, 4 times 0 to the exponent 3 minus 3 times 0 to the exponent 4, so it's equal to 0. And then q of 1 is equal to 4 times 1 to the exponent 3 subtract 3 times 1 to the exponent 4. So in this case, I should have 4 minus 3, so it's equal to 1. So then the two values is the corresponding value is 0, 0. Okay, and I should have 1 and 1. So I am going to take a look at this 2 point on the graph to see which one is the max and which one is the min. Okay, so I go here, I see right there, I am going to make a point right here for everyone. So this is 1, 1. When t is equal to 1, the value of the chart will also equal to 1. And this is the maximum values. Okay, the maximum points. Then if I have 0, 0, then it's right here. So with the 0, 0, it indicates that it's a minimum point. So this one is 1, 1, and is the minimum point. Okay, so obviously I'm sorry, why do I say I should be 0 and 0? Okay, so obviously you see that on this graph 1 and 1 is a max and 0, 0 is a min, and it's quite practical in terms of what they are asking us to find, right? So the maximum time occurs at the maximum chart of 1 and 1. The minimum times occur at 0, and resulting the 0 value for the chart as well. Okay, so you may want to ask me this question. You may want to ask me that in previous lesson, what we did, we actually have to use the second derivative test. That means you have to differentiate this again. Okay, if you differentiate this again, and if you substitute the values in is equal to 0, then the second derivative test doesn't work. Okay, so it doesn't work because practically we can just knowing that comparing the value 1, 1 and the value 0, 0, that means maximum occurs at time equal to 1, the amount of charge equal to 1, minimum occurs at time equal to 0, the charge is also equal to 0. So I would like to put here as the equation for Q, and here's the equation for time. Because when I sketch this graph for everyone, I have to identify as X and Y, but the correspondence should be the Q and the T. Okay, and this equation is actually Q equal to 4t to exponent 3 subtract 3 times t to exponent 4. Alright, so let's move on to the next example, which is more interesting. Okay, so the next example is I am having a chart equation, but this time I am asking you that find the time in second when the current in ampere reaches minimum. Okay, and what is the minimum current at this time? But I'm giving you the chart to work with. Okay, so in order for you to find the current, and then you test the current to see if it's a minimum or maximum, and you have to find the minimum current at this time. It's already indicated for me that it's a minimum chart. Then what you need to do is you need to apply two calculation here. So given Q, you can find the instantaneous current by differentiate this in terms of time. Okay, so after you differentiate this in terms of time, you find I. So that is step number 1 that you have to do. But in order to measure whether or not you have a point minimum or maximum, you have to differentiate, right? So that means I need to differentiate this equation I that I found, and then I set it equal to 0. So that means 2 steps. We have to differentiate twice. Okay, the first differentiation is to find I. The second differentiation is to find the slope, and let that slope equal to 0 because you can only measure minimum or maximum at the point where the tangent is touching that minimum or maximum point, and that tangent has to be a horizontal. So all of this will explain to us further in terms of the graph. So the first thing I would like to show everyone is this is the graph for Q versus time. So this is the graph where I put Q equal to 2t to exponent 3 minus 3t squared. This is only for the Q. Okay, so what I need to do is I need to find I, because they are asking me for the instantaneous current, and they ask me when does instantaneous reach minimum. Okay, so that means I am going to find I first. So the formulas to find I, as we learned in previous lesson, is to differentiate Q in terms of time. Okay, so Q is given to me at 2t3. So in this case, I should have 6t to the exponent 2 minus 6t. Alright, so at this point, this one is my I. So I'm going to write I equal to 6t squared minus 6 times t. And then they asking me for this, okay? Find the time, okay, when the current reaches minimum. Okay, again, in order for me to measure the minimum or maximum, I have to differentiate, right? Okay, we need to differentiate to determine the minimum or the maximum. So because what is differentiation? Okay, so what is di over dt in this case? Because I am finding the slope, okay, of that line. Okay, so I'm finding the slope at certain points, and then I am going to set it equal to 0. So di over dt now is equal to 12t minus 6. Okay, so I am finding the slope of this is a straight line now. Okay, so this tangent to this graph is a straight line, and I'm going to set it equal to 0. Okay, so I am going to now let the di over dt equal to 0. So therefore, 12t minus 6 equal to 0 to solve for t. Okay, so when I set this equal to 0, I can find the t by 12t equal to 6. T equal to 6 divided by 12. So in this case, I have 0.5 second. All right, okay. So the next step is to substitute t equal to 0.5 second into the I equal to 6t squared minus 6t to find the corresponding value for I. All right, okay. So this is very important because it's just so easy that we are going to substitute into our original equation, which is q, but it's not, this is the q given to us so that we can find I. And they are asking for the minimum I, okay? So therefore, we need to find the corresponding I at that value t equal to 0.5 second. So I will write it here. I of 0.5 will be equal to 6 times 0.5 all of it square. Subtract 6 times 0.5. So I will have 1.5 subtract 3. I will have negative 1.5. I'm going to put in significant digit here. So it will be negative 1.50 amperes. All right. Okay, so I would like to show you how I present this on the graph. So this is the graph of I versus time. Okay, so this is I equal to 6t squared minus 6t. It is a parabola. Okay, it is a parabola representing the I, and at the point t equal to 0.5, I got the corresponding I as negative 0.5. So that mean is right here. Okay, so let me click that for everyone. So this point representing the 0.5 and negative 1.5 according to this graph. Okay, so you see, obviously, it's a minimum current. Minimum current is equal to negative 1.5 and occurs at the time equal to 0.5 second. Okay, so you probably ask me minimum point. Okay, sorry, but I kind of pause a moment. I want to write down here is the minimum point. All right, okay. So you probably ask me, what about the derivative test? Can we try the second derivative test? Yes, we definitely can. Okay, we can try second derivative test to see if this one is proven to be a minimum point. Okay, so to choose the minimum point, Okay, so I will have I. Okay, so I equal to 6 t squared minus 6t. Okay, so now I prime, right, is 12t minus 6, or this is my di over dt. And then I can have to find the double prime of I. So I have to find the second derivative of this I. So then I should have 12, right? So this is absolutely greater than 0. Then what I'm going to ask you to recall, in previous lesson, we kind of make calculus fun by drawing this phase. So in here, I have the second derivative. So the 2 line here is showing that it's a second derivative of the 2 hairs. Then I will have it's positive. It means he's smiling. If he's smiling, right here, I should have a minimum point. Okay, so minimum point, as I found, this is the I double prime is positive. Okay, I should indicate this is measured in ampere, T measured in second. Okay, so you can conclude for this question, you can conclude that at the time I equal to 0.5, the minimum current reaches negative 1.5 amperes. And I also want to emphasize to everyone that this question given us this function in terms of Q. So we have to find the equations, okay, to find the equation for current before we can determine the time at which the current reaches minimum. So finding the equation for I, then given Q, we differentiate Q in terms of time, then we find the equation for I. And to determine whether or not it's a maximum or minimum, it's related to the slope of the tangent line equal to 0. So you are going to find the slope by differentiating I in terms of t, and we find the solution right here, and set the slope equal to 0. Okay, so set the slope equal to 0, solve for the time, substitute into the equation for I to solve for our corresponding values, and we sketch, and it's obviously is a minimum point. This parabola opens up, and we can also use the second derivative test to prove it is a minimum point by differentiating I twice. Alright, I do have a few questions I would like everyone to try. Okay, so I have the graph here, and the questions are here for everyone to give it a try, and to make sure that you master the concept of maximum and minimum. And when we talk about maximum and minimum, we are talking about differentiation, and set that differentiation equal to 0. And if we want to test whether or not it's maximum or minimum, we have to find the second derivative, okay? And then maximum or minimum point relates to the phase that I have shown everyone earlier, okay? So either the happy phase or the sad phase. Alright, thank you everyone.